Okay, bonding in esters and the chemicals that make them, the corresponding alkanoic acid and alkanol. Remind you that molecules can be polar or non-polar, and for a molecule to be polar, we have to have an electronegative element present, and they are fluorine, oxygen, nitrogen, and chlorine that we remember as Fonkel, and they the molecule themselves must have asymmetry, have a positive and a negative end. Now our ester here is a polar molecule because it has the presence of electronegative elements and a positive and negative end. Not shown all that clearly in this diagram, but I remind you that the oxygen, when bonded to two other things, is bent because of the two sets of lone pairs that influence the shape. So it's polar. The ethanoic acid is polar and the methanol is polar. Again, based on this bent oxygen because of the influence of the two lone pairs. Now, all of the molecules will have dispersion forces between them, but dispersion forces are very weak. But we can write them in, we can acknowledge that they exist. So between ester molecules, there are dispersion forces. Between ethanoic acid molecules, there are dispersion forces. And between methanol molecules, there are dispersion forces. Now, with respect to polarity, the hydrogen bond is possible here because the electronegative element is bonded directly to hydrogen, so the strongest polar molecule exists in ethanoic acid, and similarly in methanol, the electronegative element is bonded directly to hydrogen, so we can have a hydrogen bonded molecules. Methanol molecules interact with hydrogen bonding. We have a third type, however, present in the ethanoic acid molecule because we have this part here that's also has a charge separation with that oxygen taking its share of electrons away from the carbon. So between those molecules of ethanoic acid, we also have normal dipole-dipole. So just this type here, fairly strong forces between molecules. Within the ester, that's also possible because we have this functional group still present, so dipole-dipole as well. Remembering that D is for dispersion forces in all of them, and these are for dipole-dipole, this type of normal polar molecule. To sum up then, the forces between the acid molecules will be the greatest because there are three types of bonding between alkanoic acid molecules. There is the weak dispersion, there's dipole-dipole, and there's hydrogen bonding, so that the acids tend to have the highest boiling points, the largest forces between molecules, followed by the alcohols. Here our example being methanol, because here we have two types of bonding present. In this polar molecule we have hydrogen bonding and dispersion forces, so it will have the next highest boiling point because of those forces of attraction between molecules, and the lowest one, hence why we need to reflux, will be between the ester molecules, because we've lost the power of the hydrogen bond, which is the greatest forces of attraction between molecules, and we're down to just having dispersion and dipole-dipole. So it has the weakest attraction between molecules and hence the lowest boiling point.